Let us take another aspect in the measures of relative location, and the topic is Chebyshev's theorem. According to Chebyshev's theorem, at least 1 minus 1 upon z square of the data values must be within x bar plus or minus z standard deviations. If we multiply this factor by 100, we get percentage. That much percentage of the data value must be within the mean and so, rather z times of standard deviation. For this purpose, we need the z. What is z? Z is, say, any value which is greater than 1. Why should the z value greater than 1? Because if z is exactly 1, this factor comes to 0. So, not to get 0, rather the meaningless answer like 0, the z value should be greater than 1. Only if the z value is greater than 1, we can have some positive answer of this factor. Now let us take an example. For a sample, the mean is 30 and standard deviation 5. We require to use Chebyshev's theorem to get the percentage of the data values which must be within these ranges. Let us take the first range. The range is 12 to 48. First of all, we have to calculate z value by the formula of z score for 12 and 48. We know that z equals to data value minus mean divided by standard deviation. So, in this case, the first z will be 12 minus 30 divided by 5. It comes to
minus 0.7.
No. It comes to minus 3.6. Is it?
3.6.
For second value 48, z comes to 48 minus 30 divided by 5. So z comes to positive 3.6. That means for this range the z is plus or minus 3.6. We are going to take the squared value of z, so it is immaterial whether z is negative or positive. But now let us substitute the z value in this formula. 1 minus 1 upon z square equals to 1 minus 1 upon 3.6 square. That means 1 minus 1 upon, get the answer, 3.6 square. 3.6 square comes to
3.6 12.96.
Yes, it is 12.96. Now get the answer of the entire fraction. 0.92. That means if we multiply it by 100, we get approximately 92%. So the interpretation is at least 92% data values must be within 12 to 48. For this particular sample data, at least 92% data values must be within 12 and 48. Only 8% values are there. Some of them can be less than 12 and remaining can be greater than 48. Okay, it is at least 92%. That means there is a possibility that all the values are between 12 and 48. At least 92% means from 92% to 100% data values must be within 12 to 48. In the same way, we can calculate z score and then the value of this factor 1 minus 1 upon z square and get the answer in percentage or anything. 0.92, the interpretation of 0.92 is somewhat not good, so I prefer percentage, 92%. Now the next is 15 to 45. 15 to 45. First Z for 15 will be 15 minus 30 divided by 5. So Z comes to minus 3. Similarly, Z for 45 is 45 minus 30 divided by 5. For that, Z comes to positive 3. That means for this range, the Z value is positive or negative 3. Again, let us put the value of Z in the formula. One by 9, it comes to approximately 0.11. So the factor comes to approximately 0.89, that is 89% approximately. That means at least 89% of the data values are within 15 to 45. Again, the word at least 89% means from 89% to all 100% data values are within 45 to 40, within 15 to 45, very sorry. Now the third range given is 18 to 42. It is 18 to 42. Again, the first value of Z is for 18. 18 minus 30 divided by 5. It comes to 12 minus 12 divided by 5. So the value of Z is minus 2.4. For 45, or rather 42, Z value is 42 minus 30 divided by 5. So it comes to positive 2.4. That means Z is, or Z value is plus or minus 2.4. Let us substitute 2.4 in the formula. .4 square. What is the value of 2.4 square?
5.76.
Now we can have the value
0.82.
82 approximately. That means we can say that approximately 82%. So the interpretation will be at least 82% of the data values are within 18 to 42. Within 18 to 42, or from 82% to all 100% values or data values are within 18 to 42. The fourth range given is 20 to 40. 20 to 40. Z value for 20 is 20 minus mean 30 divided by standard deviation 5. So it comes to minus 2. Z value for 40 is 40 minus mean 30 and standard deviation 5. That means it is positive 2. That means the Z value for this case is plus or minus 2. Now let us substitute the value in the formula. 2 square, that means 4, that means 1 minus 0.25 is 0.75, that is 75%. So we can now say that at least 75% of the data values are within the range 20 to 40. Or say from 75% to all 100% data values are within 20 to 40, so far as this particular sample data is concerned. And the last range given is 22 to 38. 22 to 38. Z value for 22 will be 22 minus mean 30 divided by standard deviation 5. It is minus 8 by 5, so it comes to minus 1.6. And Z value for 38 is 38 minus mean 30 divided by standard deviation 5. So Z value comes to positive 1.6. That means for this case the Z value is plus or minus 1.6. Now let us substitute 1.6 into the formula. 1.6 square is 2.56. 1 minus 1 upon 2.56.
0.60.
0.60. That means approximately 60%. That means at least 60% of the data values are within 22 to 38. Or say from 60% to all 100% data values are within 22 to 38. So this is the interpretation of, say, the percentage of data value which can be within the particular range of the two data values, lower limit and upper limit. Yes, thank you.